Welcome to the Trash AI homepage. I am Dr. Wynn Cowger, a research scientist at the Moore Institute for Plastic Pollution Research. And this is a project that I'm working on in collaboration with Code for Sacramento, Open Fresno, Caltrans, and the lead developer on this project is Stephen Hollingsworth. He's put in a ton of effort to make this happen. Trash AI was really inspired by the need to collect data on trash in the environment. There's a lot of trash out there. We want to keep our environment clean. One of the ways that people collect data traditionally is they use a survey sheet. They'll record every little piece of trash that they see, and this can be very time intensive and isn't very automated. Some of the newer techniques that are coming out for recording data on trash in the environment is one of them is mounting a camera on a car and having that car drive by and recording all of the images that you see. If we could have a way to be able to upload all of that recorded imagery and extract all of the data, we'd have a lot better understanding of trash in the environment and better be able to manage it. So that's just one example of something that the Trash AI was built for. Another one is a lot of people these days are starting to use cell phone apps to record images of trash that they see when they do clean surveys. And that imagery can be fed into something like Trash AI so that you can quickly analyze those images. So I'll dig into, this is going to be a little bit more of a detailed tutorial than one of the previous ones. So I'm really going to get into the applications of this and all the nitty-gritty of how this tool works. Over here on the left-hand side, we have three different tabs. We have the About page, which talks about the project and how you can be involved. We have the Uploads page here, where you can initiate uploading data, and then a Summary tab, which will start to get filled up after you've uploaded some data. There's also some tabs up here in the right-hand corner. So there's a light dark mode toggle, you can change it into dark mode. We have a link to our GitHub page. This is a open source project. And so you can contribute to this code or use it for other purposes. We have a lot of contributors already, 15 contributors, and this package is really starting to take off with lots of applications. Also, the Code for Sacramento homepage is here. They have many other projects that they're doing beyond Trash AI. They really put in a lot of great work to help the community using their coding expertise. So to get started, if you don't have any images, you can click this Actions tab and then click Show Samples here. And what this will do, we have some sample imagery that's saved on the back end of the app, and it will just load up that sample imagery so that you can see how Trash AI works. And once the imagery is loaded, it's actually loading in your browser. So there's this database called IndexedDB that is in your browser. So all the images stay there. We're not taking them anywhere else. And all of the AI is being done through TensorFlow.js, which is also happening in your browser. So all of the computation is happening on your computer. And so this allows us to really scale this project, because we don't have to have the server infrastructure and the database infrastructure on our devices. We're just basically providing you the tools so that you can run this type of analysis on your own device directly in the browser. After the images are loaded, you can see the IDs here. And before we dive into the IDs, I'm actually going to load some of my own imagery so that you can see how that works, because most likely you don't want to just test our sample data. You want to look at your own imagery. So to clear, if I uploaded some additional data here, it would actually just add that onto the sample imagery. But what you want to do is clear it so that you can upload your own data. And I'm just pulling up my data here. So I'll show you what that looks like. So I'm going to grab 25 images from a trash survey that I did where I photographed every piece of trash. When I was collecting these images, I was allowing my phone to record the GPS location. So that's a setting that you'll want to turn on so that you can make the most of this tool, because that information is in the metadata and we can use that. So we have 25 pieces of trash that were recorded during a trash survey, and I can let's see here. I can just drag those over, and you'll see the same thing is happening as what's happening with the survey or the sample data. The process is starting to upload all of the images, and then TensorFlow JS is identifying any trash that's in the images. And that happened pretty fast. That's only 25 images, but you can really scale this up to however big your device can handle. So we've tested this at the scale of over 1,000 images, but it could probably go even bigger than that. So we can talk a little bit about how to analyze this information now. So if you go to the summary tab, the detections tab here is going to tell us what has been detected in the images. So we can see plastic film is being detected most, unlabeled litter. This is the number of times that it was detected. Styrofoam pieces, clear plastic bottles, cigarettes. So that'll show you the detections. And then we can click these detections and look at the images of that. So this will show us all of the images with plastic film in the image. And if you click summary again, it will basically refresh, so you're not filtering anymore by the type. And then you could click another one, look at the unlabeled litter images. And I want to really demonstrate here a caveat of this tool currently. One of the main limitations is that the AI algorithm is not yet as accurate as we would like it to be. And so if you have that expertise or you have some labeled images you'd like to share, we would really appreciate sharing those so that we can get them onto this tool and use this tool to better help the community. You can see here that, you know, there's misidentifications here. It's labeling something as a plastic bottle, but that's just a piece of dirt. Some sort of unlabeled litter over here. Similarly here, it's completely missing the trash. So you can see that there are some issues, but this is really a great improvement over the previous status quo where we didn't have any access to these AI algorithms. We couldn't automate this type of procedure and would have to manually label anything that was in the images. If you click the photographs, you can look at photograph scale information. So it'll tell you what is in that photograph: plastic film, clear plastic bottle, unlabeled litter. You can also look at the metadata that's being extracted for that piece of trash. So this is showing us the JSON. We'll get into that a little bit more later. And then you can look at where that piece of trash was on the map. Again, if you click summary, you're going to be removing that filter that was put on where we were just looking at the one image, and now we're looking at the whole bulk images. Moving on to the no detections tab. So this is the images that don't have that no trash was identified in them. And all of these images should have trash in them because I was only taking images of trash. So definitely these are ones you really want to look at and make sure that you're getting the IDs that you want. Then we can go to the map summary tab, and this will show us where on the map all of the pieces of trash were found. So we can see here, I was surveying this river channel here, and so we have all the points clustered over there. Now I'm going to show you a little bit more about how you can use this data. So we have a bulk download feature, so you can download all. And when you do that, it will create a zip folder. And I'll show you what that looks like here. So this is inside of the zip folder for the images that I uploaded. And what you can see is that for every image, we actually re-download that image that's in the folder, the raw image. And then there's also a new image that gets created for any of the trash that got labeled. So let me find one that had a label here. So we have the image with the label here. And let's find the original image here. So we have the original image, and then we also have the label on the image, and those both have the same exact name, but the image with the label, I think, ends in the word detect. So it'll have detect.jpg. So that's one of the pieces of data that you get. And then another one is for every image using that same exact unique identifier, there is a JSON file. And that JSON file looks like this, but I will make it look nicer. So we can view that JSON file. Basically what I did, I just copy and pasted over the text for the JSON file so that we could look at it as a tree. And this can be a little bit easier to see. So we have the EXIF data. This is the data from the metadata of the images. So we have the type of phone that the image was collected on, the GPS coordinates, timestamp, image dimensions. And then if there's any trash, we get metadata on the trash. So it'll tell us the ID confidence, it'll tell us the label, it'll tell us the bounding box location of the trash in the image. So that just gives you an idea of what the image scale JSON objects look like. And then we also have summary scale JSON objects. So this is the summary one. And this will give us for all of the trash that's detected in images. This will give us just gonna paste that in here again so that we can see what the JSON has in it. So this will give us the information about all of the images whenever trash is detected in them, and some summary stats of, so you can see here, plastic film. So detected objects, plastic film, there was 8 of them, and these are the images that plastic film occurred in. Unlabeled litter, there were 5, and these are the images that unlabeled litter occurred in, and so on. Also, it will tell you the images here where there was no detection. It gives you some totals. And then also GPS coordinates for each of the images. So this is just giving you some additional data that can be useful to have on hand. Okay. And then we recently made three different CSV files because we realized that a lot of researchers don't commonly use JSON files. So we made some CSV files, and those are just comma separated values. Actually, these are semicolon separated values. So you can see here name, count, hashes, and so you can read that into any like Excel or Google Sheets and process your data that way too. So the summary detected, that one that I was just showing you, oops. This one has the name of the trash, the total count, and then the hashes that are associated with that. Summary GPS has the coordinates for the spatial coordinates for all of the images. And then summary totals has just the total counts for all the trash. Then we also have schema information. So if you want to validate the way that these JSON files are structured, or you want to better understand them, so we have, for example, an image schema description. So describe every single, this will describe every single object within the JSON file. And then we have the JSON schema, which you can use in a schema validator to validate the JSON objects. So if we want to go here, we can copy this. I'll pull up a JSON schema validator tool. So we have the schema here. I just pasted that in, and then I'll bring in one of the images so that you can see what that looks like too. So this is an example of, let's see, let's do this one because we're already working with this one. This is an example of one of the image schema or one of the image JSONs. And this says that no errors were found. JSON validates against the schema. So that's great. That's exactly what we want. It just basically goes through and type checks everything to make sure that it's the right format. And it will let you know if there are any errors in that format or anything unexpected. One thing I know that will occur with this is that some of the photographs, sometimes people don't record the GPS location of the photographs. And so some of this EXIF data may be missing from images that are using this tool in certain cases. So that may be something that gets flagged. We can also validate in the same way the summary table. So here we have the summary schema, and we can copy that, bring that into the schema validator, and then here we can pull up the summary, bring that in. Oops. So now I just brought in there was an error before, but that was because I had the image scale JSON in here, and I had the summary scale schema, so that makes sense. But now we have the summary scale schema, and then we have the summary scale JSON objects, and now that's validating correctly. So that's looking good. Okay, now I am going to talk about how to use this data once you have it. So you have this data, that's great. Now what's the best way to use it? How can I analyze it in some other program, for example? So there's lots of different ways you can pull in these CSV files into Excel or Google Sheets and do some analysis there. I personally use R a lot to do my statistical analysis. I know a lot of other colleagues that I have do. There's also Python. A lot of this tool was built in Python, so that's another way that you can analyze this data. There's tons of different ways, but I'm going to show you my personal use case of how I would get started analyzing this data. And I'm also going to share some code, some R code for this analysis that you can use. So this is the R code. I have RStudio opened up. And I have named that data download, that zip folder that I downloaded. I've given it a name of example data download 2.zip. And I've put it's going to be shared so you can redo this analysis on your own device. But I've put it in the notebooks directory inside of the data reader directory on our GitHub repo. And if you end up changing the directory of that package, or you want to change the code, you can just change this reference here, and that will make it so that it knows where to find your data. So I'm going to set the working directory here. We're reading in 4 different libraries for this analysis. Then we are using this import list function to import any JSON files that are inside of this zip folder. Then we want to get the path of the summary table. So this will tell us where the summary table is. Get the paths of all the images. So here we can see these are where all the images are, all the image JSON files. And then we filter out just the summary data from the JSON list, and we flatten that. There's a lot of different ways you could flatten this. For me, I really just care about getting the name and count, but there is additional information in these JSON files. If you want to extract it, you can build that in. But for me, with the summary data, I'm just interested in the name and count. Then we can also extract the filter out just the image data from the whole zip folder, and then flatten the image data so that we can get just one flat table. And for that, so again, there's more information in that JSON file if you want to extract it. For me, what I wanted the hash of the images, the file name, I wanted the date time, the latitude, longitude, the score, the accurate confidence score for the identification, and then the label. And then this just forces it all to fit in one sheet. And we can test some basic logic to make sure that these two data representations are producing the same information. So this test essentially checks to make sure that the count, if you take the count from all the independent image JSONs, is equal to the count from the summary table. So that should be true. And then I'm just going to start with a pretty basic use case example to show you what this tool can do by creating a basic plot that shows, the top types of trash that were found during this survey. So there's a lot of other things that you could build into this. You could have additional metadata that's linked to your image file names. You could then join that into your table and do some analysis across a bunch of surveys. You could look at trends through time if your data had some sort of time scale to it. You could try to project this into a spatial analysis and do spatial analysis with it too. So ton of different things, ton of different applications that we can do here. And like I said, I'm gonna share that R code in the YouTube video, and it'll also be on the GitHub. So I want to share the GitHub repo with folks so that you can see that a little bit more. So this is the GitHub repo, and we have all of our documentation here, instructions on how to contribute. There are weekly meetings where collaborators are working together to advance Trash AI. We also have a publication pending. Thanks so much for watching. I really hope that we get to work together to advance Trash AI.